Good morning, students. On behalf of Dr.A.Q School System, Shagadi Campus Kohad, I welcome you to this video. In this video, we will be discussing subject mathematics, unit number 1, matrices, exercise 1.5, question number 2, 3 and 4. Question number 2 is, find which of the following matrices are singular and which are non-singular. Solution. The first matrix says matrix A is equal to 5, 3, 2, 1. Now we need to find out if this matrix is singular or non-singular matrix. Alright, so how do we do that? We actually find the determinant of the matrix. So the determinant of the matrix A is equal to 5, 3, 2, 1 inside perpendicular lines. Now what do we do? 5 multiplied by 1 minus 2 multiplied by 3. So we get the answer 5 minus 6 is equal to minus 1. So the determinant is minus 1, and this minus 1 is not equal to 0. Therefore, A matrix is non-singular matrix. This matrix is not a singular matrix. Had it been the case, if this determinant was equal to 0, then this matrix was supposed to be a singular matrix. But in this case, determinant is not equal to 0, therefore this is a non-singular matrix. Coming to matrix B is 3, minus 6, minus 2 and 4. Now again we find determinant of B. Determinant of B, 3 4s are 12, and then minus 2 multiplied by minus 6. So on solving we get 0. So in this case determinant is 0, therefore this B is a singular matrix. Similarly, for the part C, we find the determinant and we find out that determinant is equal to 7AB, which is not equal to 0, thus C is non-singular matrix. Similarly, for the part D, for D matrix, determinant is equal to 0, therefore this D matrix is a singular matrix. Now before going to the next question, there is this new concept, adjoint of a matrix. What is adjoint of a matrix? I'll show this to you with the help of an example. For example, if we have a matrix A is equal to A, B, C, D. Now what will be the adjoint of this A matrix? What do we do? Elements on the main diagonal, this A and D, we will just change the position of these two elements. You can see over here, adjoint of A. We have changed the position of this A and D. This becomes D and A. And at the same time, we will just change sign of the elements on the secondary diagonal, which are B and C. So we have written over here minus B and then minus C. So this is called adjoint of A. Now coming to question number 3, find the adjoint of the following matrices. This question is quite easy. We will just change the position of the elements in the main diagonal, and then we will just change the sign of the elements in the secondary diagonal. Alright, so this is matrix A. Adjoint of this matrix A will be, we need to change the position of the elements in this main diagonal. So this will become 4 and 1, and then we will just change signs of the elements in the secondary diagonal. This will become minus 2 and minus 3. This is it. Similarly, for the matrix B, we just need to change position of the elements in the main diagonal and then sign of the elements in the secondary diagonal. So this is the adjoint of B. Similarly, adjoint of C and then adjoint of D. Now before going to next question, there is this new concept which is using adjoint method to calculate inverse of a non-singular matrix. Now we will be using adjoint to find the inverse of a non-singular matrix. There is this formula, you need to memorize this formula. We have a matrix A is equal to A, B, C, D. Alright, so first of all what we will do, we will find the adjoint of this matrix A, and then we will find determinant of this matrix A, and then we will find the values of adjoint of A and determinant of A in this formula, which is A inverse is equal to 1 divided by determinant of A and multiply by adjoint of A. Or simply we can write this as adjoint of A divided by determinant of A. Now coming to the question 4, find the multiplicative inverse of the following matrices if they exist. Now multiplicative inverse will only exist if the determinant of the matrix is not equal to 0. If the determinant of a matrix is equal to 0, then multiplicative inverse does not exist. Alright, I'll be only solving this part second of this question, matrix B. You need to solve all these questions by yourselves. So coming to the solution of the matrix B, we need to find out the inverse of this matrix B. Steps are quite simple. First of all, we will find out the determinant of this matrix B, which is 3, 4, 1, 2. And then if we find out the determinant, 3 2s are 6, minus 4 1s are 4, 6 minus 4 is 2. As this is not equal to 0, therefore this B is non-singular matrix, therefore B inverse exists. Alright. And if in the other parts of the question, if you find out that the the determinant of the matrix is equal to 0, you will not proceed further. We will just simply say the matrix is singular matrix, therefore inverse does not exist. But in this case, determinant is not 0, therefore the matrix is non-singular and therefore inverse of this matrix exists. So what do? We have already found out determinant of B. We will now find out what? Adjoint of B. So adjoint of B is, the B matrix was 3 4 1 2. We just need to change the position of this 3 and 2. We have changed the position, so this becomes 2 and this one is 3, and then we just need to change the signs of this 4 and 1. So this is minus 4 and this is minus 1. So this is the adjoint of B. Now what is the formula? Formula is B inverse is equal to adjoint of A divided by determinant of B. Sorry, adjoint of B divided by determinant of B. So we will just put the values. Adjoint of B is 2 minus 4 minus 1 3. We will just write the adjoint of B over here, and then divided by B determinant. So B determinant is over here, which is 2. Now in the next step, what do? We just simply need to divide each and every element by 2, and this will be your answer. This is the end of this video. I hope you have understood the concept. If there is any question, you can ask me anytime. Take care of yourselves. Allah Hafiz.